or decrease by a constant difference. And this is your equation. This is the generic equation. You need to know this. This is where what you would, memorize or write in your formula sheet or cheat sheet or whatever you want to do. This is what you would copy down. So Tn, once again, is just your term in the sequence. A is the first value of the first term. D is the common difference. So if it's going up by 4s or 3s, whatever, that's your D value. And N is the term number. All right, so let's apply this to a pattern. So let's apply this to a pattern, and let's apply this to a pattern. Okay, so we got our A value. What's my A value? I'll give you a hint. It's the first term in the pattern. It's 14. What's my D value? Well, it's the amount that the pattern is going up or down by. So clearly we can see this pattern is going up by 4. So my A value is 14, D value is 4. And that's all you need to solve this. The equation is as follows. That. And you can simplify the equation if you want to and do 14 plus 4n minus 4. And what do I mean by simplify? I mean like multiply the bracket and combine the terms. So I know 14 minus 4 is 10, so 10 plus 4n is the pattern. Both are accepted depending on what the question is asking, so yeah. And that's it. That was it. And now they're asking what is the value of T30? So what is the T30 means what's the 30th term? And there's two ways of doing this, or at least two ways. 14, 18, 22. So this is obviously the first term. This is the second term. This is the third term. This is the fourth term. 5, 6, 7, 8, 9, 10. And we can take the pattern and go all the way up to 30. And that's one legitimate way. But remember, that's just tedious. We don't want to waste our life handwriting patterns when we have a nice equation. We can just be like, okay, well, I know the 30th term is n equals 30. So then T30 is going to equal 10 plus 4 times 30, which is 10 plus 120, which is 130. That means the 30th term is going to be 130. That's it. Just plug it into the equation, and that's how easy this is. This first lesson is very easy. It's going to get more difficult. You'll see. This first lesson is not difficult. Maybe I shouldn't actually spend too much time on it. I think about it. Hold on. So here we have another pattern. The first value, A value, is 7 in this pattern. My D value, if you see the pattern, is actually going down. So that my D value is -4. So your equation now becomes Tn is equal to 7 plus n minus 1, -4. And I can just keep it like that. That's not an issue. You can simplify if you want to. You don't have to. So yeah, and then there's asking for the 41st term now. So what is T41? Remember, T41 means n is equal to 41. N is the term number. So n is 41. So T41 is equal to 7 plus 41 minus 1 times -4. And that's the same thing as 7 plus 40 times -4. And 40 times -4 is, what's 4 times 4? Is it 16? So yeah, 160. Yeah, so 160, and it's negative because it's the -4. So that's going to be -153. That means my 41st term is -153. And that is the answer. Very easy stuff. Now we're moving on to the next thing, which is exactly the same, and that's geometric sequences. Go downstairs, go. And here we have geometric sequence because Why? Because it's kind of like multiplying. They're going, the difference between the term values is a constant ratio. So they're increasing or decreasing by a constant multiple. And here we have our equation for a geometric sequence. So once again, just so you know the difference, arithmetic sequence means that there's a pattern with a common difference of addition or subtraction. Geometric sequence is a pattern with a constant multiple. So they have two different equations. So don't use the wrong equation for the wrong pattern. And everything else is the same in terms of a value is still the first term, n is still the term number, and tn is the term in the sequence. Instead of d now, we have r as in constant multiple. And very, very important, there is no division used ever. Division is exactly multiplication, except you're multiplying by a fraction. So if you want to divide by 2, you're actually multiplying by 1/2. If you want to divide by 5, you're actually multiplying by 1/5. So that's what that is. Okay. So here we have our first pattern. Let's see if we can apply the rule to it. So this is our geometric sequence. Remember, geometric meaning it's going up by a common multiple, and here we're going up by 3s. So my a value is still my first term, which is 2. My, not d, my r value, because it's common ratio, is 3. That's the equation. That's it. Tn is equal to 2 times 3 to the power of n minus 1. Be careful you don't do the multiplication before the exponents. You got to use BEDMAS, like normal stuff. And what's the 9th term? T9. So n is equal to 9. T9 is equal to 2 times 3 to the power of 9 minus 1, which is 2 times 3 to the power of 8. And I cannot do this in my head because, actually, maybe I can. It's been a while. But it's going to take me like a year to do it. Like, I'd have to write it down now, so I can't really do it in my head. I lied. The number's not that big. Maybe I could have done it. Anyways, just use the calculator and write it out. T9 is equal to 13,122. That's it. Very basic stuff. Let's do it for one more. Oh no, that doesn't really matter. Let's do it now for this example here. We have a geometric sequence. How do I know it's geometric? Well, we know that 270 to 90, I'm not multiplying anything because obviously I'm going smaller. So it's got to be, how do I figure this out? Well, all you got to do is take 90 and divide it by 270. And what's 90 divided by 270? Let's see. 90 divided by 270. It's 1/3. Or 0.3333. Now, I'm going to do the same thing. 30 divided by 90. I also get 1/3. I'm going to do 10 divided by 30 just to make sure. And yes, the pattern is constant. If this 1/3 was not the same, this is not a sequence then. So the sequence has to have the same pattern every single time. And the pattern can't change. It has to be a constant pattern. So here we have a common ratio of 1/3. My a value is 270. So my equation is, remember, a times r. So 270 times r, which is 1/3 to the power of n minus 1. That is my equation. And clearly this sequence is getting smaller and smaller. So what's my 9th term? The 9th term, remember, 9th term just means that n is 9. So T9 is equal to 270 times 1/3 power of 9 minus 1, which is 270 times 1/3 to the power of 8. And it's going to be very similar in that, let me see, 1/3 to the power of 8 times 270, and I got a decimal answer. because I'm using my phone